In the following video, we're going to examine how to graph a quadratic function, how to graph a parabola by using the zeros, the x-intercepts, and the vertex. And so in this example, we have the function f of x equals 6x squared plus 250x plus 750. And we're asked first to determine a viewing window on our calculator that will show a complete graph of the parabola. Now, the complete graph means, you want to see the vertex. You want to see the maximum or minimum point, but you also want to see the x-intercepts. So by the complete graph, I want to make sure I see the entire U shape for this. And so we're going to rely on our calculator to assist us with this. And so I have my graphing calculator. I'm going to go to y equals, type in my 6x squared plus 250x plus 750. So I type in my y1, the quadratic equation. Now, we want to see the entire graph, so just go to graph itself. If I go to graph itself, you can see, all I see is one x-intercept. I don't see any vertex for this. I see it's going up and to the right, and so what I'm looking at right now is this calculator showing me this part of the U, the up and to the right. I need to see, and I'm missing the left side, and I'm missing the vertex for it. So I'm going to want to extend my graph to the left. I'm probably going to even want to extend down in order to see those points. So I'm going to go to window size. And this is just trial and error. Right now I'm at -10, and all I see is this. I'm not even halfway to where I need to be. So I'm going to try, let's say, clear this out. I'm going to try -50. The x max didn't matter. I can keep it at 10 if I want, because the graph showed me the right-hand side. X scale is what you want to go by on your intervals on the x-axis. Now, I don't want to go by ones because I'm going all the way to 50 on the x minimum side and 10 on the other side. I don't want to have 50 dashes to the left of the y-axis. So I'm going to go by, let's say, 5s. And that'll make it so I only see 10 dashes over there, and the right side I'll have 2. Now let's go to our y-min and our y-max. Now, we couldn't even see any part of our vertex. I mean, I was way off on the vertex on the -10 to 10 scale. And it looked like it was increasing fast and fast and fast. And if you look, you have a y-intercept of 750. It's going down. You got large number, large number. So I'm going to make a large number for my y-min. Let's try negative. I'm just going to try this time. We might need to change it. Let's just try -1000. And I'll make my y max, let's go 100. Again, you don't want to have a scale of 1, because if you have a scale of 1, you're going to have 1,000 dashes, below the x-axis and 100 above. So let's go by a y scale of 100. Now, I don't know if this is going to be accurate, but take a look at my viewing window, and I'm going to hit graph. So now I can see my x-intercepts. I see both of them. I see more of a U shape than I did originally. However, I don't see my vertex. So I've completed this part of my graph. I'm missing the vertex part. And so what that means is I'm going to have to change my window size, my y minimum, and go down. So I tried -1000, that didn't work. So let's try -2000. I'll still keep the y scale because that's only going to be 20 dashes, 20 intervals. And so this is the viewing window I'm going to use. Let's take a look and see what happens. I see my x-intercept, I see my vertex, and I see my other x-intercept. I have my entire graph now completed for it. And so there you go. My viewing window is -50 for my x-min, 10 for my x-max, a scale of 5, -2000 for the y-min, 100 for the y-max, and a scale of 100. So I want to determine the zeros. I want to determine the x-intercepts of this graph. And again, we can use our calculator for this. If we go, and remember, anytime you want to find anything on your graph, you go to the calculate menu, which is above your trace in blue. So hit second trace. You look at option 2, it says 0. So I'm going to hit enter. Left bound and right bound. Left bound means you want to mark a point to the left of my x-intercept. Now this y1 is in the way, but I know that I am actually going to have an x-intercept when this y value goes from a negative below the x-axis to a positive. So I'm going to keep hitting left, and I see I'm at a positive right now. So I'm above the x-axis. So I cross the x-axis. I'm going to mark that point. I'm going to go to the right until I'm below the x-axis. And then the guess will be in the middle. And so you have negative 38.41. And negative 1 e to negative 10th means, that's 0. So there's my first one. Let's do the same thing. We have 2 zeros for this. And so I'm going to go second, calculate, 0. Left bound, right bound. I mean, I want to go until I am to the left. This will be easier to see of this x-intercept. Now I'm already to the left of it, but I like to make it close just so I can see. There's my x-intercept. Here's a point left bound. Gonna go to the right of it. I know I'm to the right because now I'm in the positives for y. And guess, just hit enter again. And my next 0 is negative 3.25 on the y-axis. So these are my 2 zeros. Negative 38.41. So let's write this down. So my zeros are x equals negative 38.41 and negative 3.25. Determine the vertex of the parabola. So remember, when you want to find the vertex, what you need to do first is you need to find your axis of symmetry. And this is what we covered in the first lesson. And so the axis of symmetry is x equals negative b over 2a. Our b was 250, so x equals negative 250 over twice a, and a was 6. So we have negative 250 over 12. And so we have x equals, if you were to simplify it, negative 125 over 6, which is approximately negative 20.83. And so if I want to find the vertex, I'm going to rely on plugging that value in to my original function, which was y equals 6x squared plus 250x plus 750. And so the x value I'm plugging in is negative 20.83. So negative 20.83. And if I were to put this into my calculator, I would get y equals negative 1,854.16. And so the vertex is negative 20.83, negative 1,854.16 for my coordinate. And the last part says we want to graph this using its zeros and its vertex. And so what's nice, if I go up, we're going to use our scale. We're going to use the scale we used in our calculator to assist us with actually creating a graph for it. So I'm showing, my x min is negative 50. So then I'm going to label, the lowest point I want on my graph, is negative 50. My highest point I have is 10, so let's go by intervals of 10. So I want to go, let's say this is negative 10, negative 20, negative 30, negative 40. Here's positive 10. The y max is 100. The y min is negative 2,000. So I'm going to go down. I want my y min of negative 2,000. Halfway is negative 1,000. Here's negative 500. Here's negative 1,500. And if you want, you can do your 5 intervals to get there. We're just going to estimate this. And so the information I want to know is, my zeros. My zeros were negative 38.41 and negative 3.25. And so the first piece of information I'm going to graph is I'm going to graph my zeros. So I'll use green to graph the zeros. So negative 38.41, let's just approximate it, that's around there. And negative 3.25, let's say, is around there. And so there are my zeros. My vertex is the next piece of information I want. So I got negative 20.83 for this. So it's a negative 20.83 and negative 1,854.16. So negative 20.83, let's use blue for this one. That's probably about right there. Really close to, negative 20. All the way down to negative 1,800. And so we're probably around this area right here. So that's an approximation. And then I'm going to sketch my graph. And so it's a U shape coming up and going through my zeros. So I have my zeros. They were labeled for me. I found them with the graph calculator, and I found my vertex and a graph. Did the U shape through the zeros and the vertex. So we can try for this when we're going through, we have to use our window scale on our calculator to assist us. We learn to find the zeros. You have to do a left bound, right bound for the graph, just like how you found the max and min before previously. Find the vertex by doing the axis of symmetry, and then plug it in to get the coordinate of the vertex.